Hello, and welcome to our webinar about game development with Unity and Rider. Hi, Matt.
Hi there.
Yeah, so this is actually the first webinar of the series of game development webinars we're going to host this month in January and February. So follow the link to register for other episodes or for similar webinars in Korean, Chinese, and Japanese if you prefer that. So these free webinars will teach you Rider and Rider Flow tips and tricks so that you can craft best games with Unity and Unreal Engine. And our speaker for today, Matt Ellis, JetBrains developer advocate, a contributor to Unity support in our tools. So hi, Matt, how are you doing today?
Doing well, thank you. Looking forward to this. It should be good fun.
Cool, great. So talking about games, actually, my family did Mario Kart during the New Year holidays. What about you, Matt? Have you played anything?
I haven't played anything lately. It's just been far too busy. But my son's busy on different console and PC games. Sadly, I haven't had the time to sit down and play anything. So I'm looking forward to a few games. I've got a couple on my list.
Oh, cool. You were probably preparing for the webinar.
Oh, yeah. I was too busy.
Okay, so Matt will be using Rider to code today. You can download a free trial from our site and give it a go for your projects. And there is also Rider Flow, a free plugin for Unity Editor, which we'll cover in the series of our webinars later. So if anyone has tried these tools, you can share it like in the chat. We would like to know how many of our users are here today. So the main part of the webinar was pre-recorded, so you can enjoy Matt without a beard. But we'll handle questions live right after the video. So if there is something you'd like to ask, go and ask in the chat. And actually, you can ask questions in the chat on both YouTube and Twitch platforms we're streaming to today, and we'll try to answer as we go along. And in the end of the webinar, we have a live Q&A session where we'll just answer your questions, as many of them as we can, hopefully all of them. And yeah, the main part of this webinar, as I said, was pre-recorded, so we'll play the recording now, and you can just sit and enjoy and prepare your questions. So I think we're ready to start, right, Matt? What do you think?
Oh, yep, it's fine by me.
Okay.
Let's go for it.
Good to go.
Everyone, thank you all for joining. My name is Matt and I'm a developer advocate at JetBrains, and today I'm going to talk to you about using JetBrains Rider as your script editor in Unity and all the good things that it can do to help you with your project and help you work really well with your scripts and understand what your code is doing. Getting started is very easy. You just need to be using Unity. I've got a sample project already open here. If we open our preferences for external tools, you'll see that Unity has already recognized that we've got Rider installed. I can just select it from the drop-down, and then when I double-click a file, it will automatically be opened in Rider. Before we have a look at Rider, I just want to quickly show one thing there. If we go to the package manager, the support for Rider is built into later versions of Unity with the Rider package. It's always worth having a check to see if there's a newer version there and keeping that up to date to make sure you get the best experience. Okay, double-click a file, it opens in Rider, and this is what we've got for Rider. We've got the file and the source code shown very nicely in the editor there, and on the left-hand side we've got our project view. You can see here we've got a Unity window on the left here, and this is showing all of the files and folders that I've got in my project. And this is very nice because it's not showing you the solution files you've got there, but it's showing you a view very similar to the project view in Unity itself. So we can see all of our assets, and we can expand any of these folders and see what files are available in there, animations and so on. And I can also see my scripts and use that then to just very quickly navigate around and open up my C# files. But we can also view all of our packages as well. So Rider understands that Unity applications and projects have got lots of packages, and we show you where all of the read-only reference packages are. So for example, we can see there's the JetBrains Rider package itself being referenced, and you can open that up and have a look around in there as well, and you can work with the C# files that are part of those packages. Any packages that you have which are editable will be shown here as well. So I've got a copy of the Unity Collections package, and we could edit that, we could work with that, and Unity will compile that and use that for us. Let's jump back into the whole script editor as a whole. So there are two keyboard shortcuts that I want to teach you today. This is the most important thing for getting started and for using Rider. So let me just close these windows down for a second. If I close everything down, the two main keyboard shortcuts are Shift-Shift to open up Search Everywhere, and AltEnter, which I'll show a bit more shortly. But Shift-Shift is our search tool, and this gets you anywhere in your project. You can start typing, say, for menu, and it'll get me anything with menu in there. It'll search for classes, for files, for symbols. It will even search for actions across the IDE as well. So if I very quickly want to go to this tower defense main menu, I can just type menu, or I can do it even quicker. I just use TDMM, Tower Defense Main Menu. Very easy way of navigating around and getting to the code that you want. It will take me to the class or to the symbol. For example, I can go and find projectile, and there's ballistic projectile that I'm looking for, and it'll take me to there. I could go and look for start speed, which is a field being used in ballistic projectile. I can also see that it's being used in linear projectile, and I can very quickly navigate there. So it's a great way of navigating around your code. If you know where you want to go, type in the name, and Rider will take you there. The other useful thing you can do here is search for actions in the code. So if I want to turn word wrapping on, for example, I can do that. I can use the Actions tab here, and then I can click word wrap on, and I can do it just with a simple hit of Enter, and it will do it directly without even closing the dialog for you. So you can update and work with that dialog very quickly. So the other item that we want to look at, the other keyboard shortcut, is AltEnter. Now, you're going to see sometimes across the code that Rider is looking at your code and scanning it and trying to find issues that'll help you, and it will save time for you and find problems before they become a problem in your build. And so, for example, here we've got ballistic projectile. We've got an inspection where Rider is telling us that this class has some virtual members but no inheritors. We don't need those virtual members, so we can use Alt-Enter to show our menu, which can fix things. And this Alt-Enter menu can do a lot of great things. It can fix up, do quick fixes to change this. So, for example, I can make this file sealed, and that will remove those virtual methods for me. And in fact, if we go to the version control menu, I can show a diff there to see exactly what's happened, and we can see that the class has been made sealed. These fields have been made private, and some virtual methods there have been removed. If I decide I don't want those, I can very quickly right-click there and roll back, and we're back to how we were before. So AltEnter is a very useful tool which can do a lot of things. It can also do things where there aren't any highlights. So, for example, I'm on the public keyword here. If I use Alt-Enter there, I can very quickly change public to internal, or change it back to public. It's a great way of very quickly updating your code. Other really useful things we've got here, in fact, let's just get over to the name of the class. If you look at the bottom of the bottom of the menu here, we've got a few different items. We've got things like navigate to, refactor this, inspect, and generate. These are entry points to pretty much all of the functionality of Rider. If you can use this from Alt-Enter, you'll be able to get to nearly everything that you can do. So, for example, if we select refactor this, we get another menu of all the different refactorings we can do with our code. Refactorings where we can change the code to have it do the same thing, but in a different way. So, for example, here, I can safely rename the code. So instead of just going through and doing find and replace on ballistic projectile, I can very quickly change its name, and Rider will do all of that work for me, and it'll update everything. We can see that Unity in the background has recognized that and is recompiling and rebuilding. So I can do Alt-Enter, use my refactoring items there, and do a whole load of different things like safe delete as well. So if I want to just check whether I can actually delete something, is it being used somewhere else in code, we can run the safe delete, see if it's being used, and only delete it if nobody else is using it. Other items down the bottom which are really useful is the navigate to menu, and you can see these entry points have keyboard shortcuts right there as well, so you can jump straight there. but we can use the Navigate To menu to show different items. We can go to the declaration. We're already there, but that would be useful if I was here, for example. I can go Navigate to Declaration, and that takes me straight to the item. If we go to Navigate To, I can go to up and down the class hierarchy. I can go and see base symbols or derived symbols here, so I can see that. Let's go to my base symbols, and I get an option here. I can go to mono behavior, and if I navigate to that, Rider will decompile the code for me, and it will show me mono behavior as well, even though it's a Unity specific class. Go back to Navigate to base symbols. Or I can go to this iProjectile, and I can go and see the definition of this interface. And if I navigate here, I can very quickly jump to the code, and I can do a similar thing here with Navigate to Derive Symbols, and I get to see everybody who is implementing the interface there as well. So I can see my ballistic projectile, the renamed ballistic projectile, and I can see my other projectiles as well, linear, homing projectile and wobbling projectile as well. Nobody wants a wobbling projectile. So we can do lots of nice things. We can navigate around and we can work with things. Another one which is useful there is the generate code. So if I'm in a mono behavior, for example, and I open this menu, there's a lot of things I can do, such as creating equality members or overriding members for virtual classes. But down at the bottom here, we've got this Unity event functions. And if I select that, we get a nice list of all the Unity event functions that I can add to this class. So if I just select a bunch of those, then you can see very quickly they get added into my class here. And if I look at the tooltip for that there, we get to a little description there as well. We can see reset to default values, and I can click the external documentation link, which is just opened on a different window. If I bring that there, and we can see that the external documentation will open up the install documentation that I've got alongside this Unity installation there. So it's a great way of finding out the information about the different classes that you've got available to you from Unity. Let's just undo that. So click on that and roll back the changes. So again, version control helping me out here. And of course, I don't have to use that dialog there. I can just start typing as well, and Rider will recognize that I'm trying to create one of my event functions, and it will auto-complete that for me. Now, the other really useful thing that you can do with AltEnter is all of these inspections. And you can see now I've got this reset class function. And in fact, let's just create an awake function. Oops. I think I've already got awake. I've already got awake defined in here. So let's say I've just created an awake function, and you can see that now Rider has grayed this out, so that we're not getting the normal sort of syntax highlighting here. And if I hover over that, it's because Rider isn't telling me that this is a redundant event function. This event function is going to get called by Unity, but it doesn't do anything, and so it's actually a performance issue. And so Rider's telling us that there's something we can do there. If I do Alt-Enter, I can quickly remove that event function, and we've kind of helping make our code a bit better. Let me just put that back in so that I don't cause trouble. It's particularly useful for things like update, because update will be called so many times per second, once every frame. And if you are making these calls and doing nothing, then that's just, you're paying a performance price there for something that's you don't need to do. We've got a lot of other, Rider has thousands of C# specific inspections. We can find things like how to modernize your code, how to make your code use more up-to-date C# features. We can also show you when your code is not using normal naming standards, and it give you Alt-Enter fixes there to make those better. But we've got a lot of Unity-specific features, and that's what I want to show you today. The things that Rider can do to really help you work with your Unity code, and how Rider will suggest best practices for you, and it will also suggest things like sort of performance-related items there as well. So if we just navigate to, well, in fact, let's just go to my inspections folder here. I've got a few examples. We've got some nice simple examples there of where Rider recognizes the use of Unity color. And so we've got highlighting there of color red. if I just show that we're using, this is the color type defined in Unity Engine, and it's showing there we've got red, green, blue, they're highlighted. If I do Alt-Enter there, I can pick a color from a palette and I can edit those and we'll update the code directly in the place. If I drag the color chooser, where is it? Oh, no. Let's try that again. So if I bring up that, if I grab the color chooser, doesn't want to work for some reason. Well, we can usually use that to go off. There we go. Now it's working. Go off and choose a particular color under the chooser, and it will then update the code based on that. So that's a great way of being able to sort of point at your game, at some assets there, choose a color, and very quickly get that into your code. So there are a couple of different things that we can do that Rider will help you reduce the amount of time that that you spend having to swap between Unity and Rider. So for example, we've got some features when if you create a mono behavior, for example, here, if you're using new to create a mono behavior, that's perfectly valid C# and it will compile and it'll work fine. But when you go at runtime, Unity will then tell you that you can't use new on a mono behavior because Unity itself has to manage this. But we can tell you that inside the editor as well. So we can give you an inspection here to say that mono behavior instances must be instantiated with add component instead of new. And we can do Alt-Enter and very quickly fix those up and allow you to choose which game object it is that's going to add the component. Similar sort of thing with scriptable objects there. So this is about saving you time when you switch to Unity. So we can find problems before you have to switch over there. Other interesting things we can do is things like invalid method signatures. So if you're using various attributes like did reload scripts, then we can show you that actually it needs to be a static method, and we can quickly fix those up. Similar problems with, let's see, do load here is also missing static method there, and Alt-Enter, we can quickly fix those. If I have, I'm in a mono behavior there, so if I have one of my methods on an application focus, and for example, if I have that empty without the method signature there, we'll show you that that's incorrect, and then Alt-Enter can again change the parameters to fix that back up again. So we do a lot of work there to understand how Unity is using your code and to fix those before it would be a problem at runtime. Similar issues with some of the magic strings. Unity does a lot of magic strings there. So if you've got inputs, values or tags or layers and scenes, these are all handled as strings, which you won't know until runtime. But Rider can look at this information from your Unity project and give you information such as code completion. So if you're using input, you can use the getAccess method there. Rider will give you a whole set of code completion methods, which you can then use to update your code. And if there's something there which isn't defined, then we will highlight it as a warning and tell you that it's likely to fail when you get to runtime. A similar thing then with compare tag. Excuse me. The tag is not defined in tags and layers, and again that will return false and won't be useful. But we've got actual tags there, and we can show those as in a code completion list. Similar thing for if you're just comparing it against the tag method as well. So it isn't just about the compare tag function, but if you're comparing it against the tag property, then we recognize that's a tag and show you those values. Similar thing with layers and scenes there as well. Great way of providing the information in the editor without having to swap to Unity to find these errors and to get into runtime. Very similar thing is things like redundant attributes there. So for example, you can see here that we've got some serialized field attributes that are redundant. This is very, very useful because it'll show you when something is not being serialized when you think it might be. So we've got a method, we've got a string, we have a field here that is has got the serialized field and also the non-serialized attribute there. This means that it won't get serialized, and we've got a redundant attribute, and we can use AltEnter again to clean that up. A really helpful one is when you put serialized field on a property. You forget that it's all about fields, and it's not going to work with a property there. And again, we can very quickly AltEnter, remove it, but we'll gray it out and we'll show you that this is not going to work as you might think it does. Another useful feature we can do, though, is if we've got a redundant attributes here, we can actually say, well, remove all of them within the file, and it cleans up a whole bunch of things straight away. So we know that there's a whole bunch of problems there, and we can fix them. And it's not just in the file, we can do it across the folder, the project, or the whole solution as well. We can fix your code. Other related inspections that we've got is sort of to do with best practices. And so if we can have a look at some of those, let's just go to something like set float here. This is all about the best practices that Unity suggests you use while you're writing your code. And again, it's about trying to bring that advice, not just from the web pages and the documentation of Unity, but into the editor. So for example, here we've got the set float method. This is taking in a string value test. But what this method does is, the very first thing it does is it converts the string value test into an ID and uses that ID as the lookup. Instead of doing that every single time you call it, we can use this, we can create a cached property called test. If I just jump to that, and that will do it once and save the value and then use that ID instead of the string value. Again, we've already seen the problem with updates. We can AltEnter and very quickly delete that method, and we're good. But similar things then with using a tag. If we compare a string literal against a tag, this is going to allocate, and so this is going to be expensive, especially if you're doing it in an update loop there. It's actually much better to use the compare tag method, and so we can AltEnter and quickly fix that. And again, this is something that we can run across the whole project or in the whole solution even, and fix everywhere where this is a problem. We can do slightly more interesting things as well here. So for example, when we're instantiating an object, Unity will very firstly create it at a default location in the hierarchy. But then if you change the parent, Unity has to do a lot more work then to give it a different location in the hierarchy. And that can be expensive. And it's a whole lot easier if you combine everything together. And we can find this information, we can find this pattern here and suggest a quick fix. And you can very quickly fix that. And in fact, you can, again, run it across the whole project. So you can apply these best practices very easily and very quickly. Similar sort of thing with string literals in a component. So instead of using a string literal there, you can actually use a type. And you get a typed response back. It's a quicker lookup, and it's a much better way of working. Let's just jump over to a slightly different feature here. So far, we've been looking at sort of warnings and inspections here. This is a slightly different thing. This is not showing you that there is something wrong with your code, but it's giving you some information, some extra context. The idea here is that we know that an update method is called very, very frequently. And so you want to be careful about the amount of work you do in the update method, and you need to be careful about avoiding APIs, method calls that Unity knows are expensive. So for example, it's not a good idea to call getComponent inside an update method. And Rider can tell you this. Rider can give you this information. So for example, here we've got an update method as part of a mono behavior, and we can see it's being marked as an event function. And I'll come back to these in a minute. But here it's being marked as an event function, and it's got the little hot icon there as well to say that it's being called very, very frequently. And inside this method, we will then recognize various expensive methods. So we know that getComponent is expensive. So you probably don't want to call that in update. This isn't a warning. This is just giving you the information now to say that there's an expensive method here. What we can do in AltEnter is introduce a field and initialize it in start or awake, and so that will, that will then create a method, a new field. And if we go and find usages, we can see that in start we've now got that getComponent call. So again, it's not about finding errors or warnings in your code, it's about giving you that information there. We can do this in other parts of the code as well. So we know that update calls reset enemy. And so if we control click and navigate to reset energy, we can see that this is being marked as frequently called as well because it's being called from update. And in here, there's a get component call. So we know that you want to probably avoid calling get component here. And so you can then investigate further. But if we go back to where we were using reset enemy, we now realize that reset enemy is doing something expensive and give you that information. So this is a very rich set of information that Rider gives you that can be used then to decide whether you need to profile further and find out if you've got an actual performance issue, or whether this is absolutely fine, whether you're just calling get component once and it's not going to hurt your code at all. So it's up to you then to look into it a bit further. Okay, so that's the main bits of the inspections. Actually, no, there's one last thing I want to show you with inspections. Let's go to this one. This is a good example of this. So this inspection is looking at mono behavior and comparing it against null. If you compare a mono behavior against null, this is not just checking to see whether the C# object is initialized or not. It's also looking to see if the underlying Unity game object has been destroyed. And this is quite complicated, and it is something that can be easily missed, especially when we're using more of the new C# features, such as the null coalescing operator here. So this is looking to see whether MB is null, and if it is, if it's not, create a new instance of the mono behavior. But this has got an inspection here because using this operator actually avoids doing the check to see if the underlying game object is still alive. This is all quite, as I say, it's all quite complicated, which is why it's really useful to be able to do AltEnter, go into the inspection options menu, and down at the bottom here, we've got why is Rider suggesting this? And this menu item will open an explanation page. Let's bring the thing there, which explains all of the information around this. And it explains why you're seeing the inspection and also how you can fix it, how you can make the code better. The Unity inspections have these this documentation for pretty much all of the inspections, and it's a very useful way of working, of finding out and understanding why we're suggesting this. So we're not just, Rider isn't just telling you to do something so you must do it. There's a reason for it, and these documents will explain why. Okay, so that's enough on inspections. Let's go and have a look at, let's go back to my ballistic projectile. And I was going to mention what these links at the tops are. You can see here we've got, you can see the version control information there. I can also see where my code is being used in code. So for example here, if I just go back to my navigate to, I can go to find usages. This will show me everywhere that this code is being used in the project. And you can see I've got my results here. It's being used as a type argument in this ballistic launcher. And you can see the code in a preview there on the right-hand side. But what we also do, which is a lot more fun and interesting for Unity projects, is that we index your project, your scenes, your prefabs, your assets, and we get to show you where this code is being used inside your Unity projects. So here we've got my usages in code, but next to it we've got these 3 asset usages. And if I click that, we can see now that this class is being used, this mono behavior is being used inside these 3 projectiles. And if I click that, we can jump straight over to Unity, which will quickly recompile because I've been changing code. But you can see now we've got this usages window, and it's showing us, let me just reload that. Let me click. And if I go back to there, we've got this usages window, which is showing us then that it's being used inside these prefabs here. And I can double click that, and you can see it's being highlighted in the project window there. So this is a very smart way of working with your scripts, where we can see that Rider understands where your scripts are being used inside your Unity code, and we can then join those things up. So instead of having Unity and Rider, we can sort of bring those together and show where your scripts are being used. And if we look at these serialized fields as well, we can see here that this arc preference has got the value use low. We've got a fire mode being set to use launch speed, and a firing angle here being set to 15. So we can actually see where your serialized data is being used and what the value is. So I can see that my firing angle is always 15 in all the assets that this is being used in. But if we look at start speed, we can see it's being changed in 3 assets. So if I click that, I can see I've got 3 different values in the different projectiles. So if I select this particular prefab, then again, we'll see where it's being used. And we can see, projectile 2. And if I pull the inspector open a bit, in fact, let's click that, let's dock that window. So let me grab that down to there. So yeah, so if I select my projectile 2 there, and if we scroll down here, we should be able to see now my start speed there is 20. And if I change that now to be 50 and save the project, if I get back here, we should then very quickly see that Rider has picked that up as being set to 50. And so it's a great way of bringing that serialized data into your editor and seeing where it's being used. Okay, so other useful things that we do to help you with your code is, that's the file I want, is working with assembly definition files. So assembly definition files are a great way of splitting up your project into different assemblies, to make them quicker to compile, so that if only the changes within that assembly will be compiled. But there's a number of interesting things happening in the code itself. So if you've got references, for example, they might be stored as GUID to assets, which are very tricky there, but we can very quickly show it. We can show it in the editor there to show that we're referencing here post-processing in Unity collections. And we can also control-click and navigate to that. We can see now we're in the post-processing assembly definition there on the left. Or I can go to my Unity collections one, and I can see that this is we've got other assemblies that are being included there as well. And in fact, so we can keep on going. In fact, what we can also do is here we can go to navigate to and find usages, and we can see everywhere that Unity collections is being used. So if I just close these down a bit, we can see it's being used in Unity collections tests, test play mode, as part of the burst compatibility gen, and then as part of my my class there as well. If we just go back to the inspections assembly definition, then if you're using version defines here, we can show you now when we've got, if you're trying to check with a version of Unity, we'll show you what the current version of Unity is so that you understand whether that expression is going to be true or not. Same with packages there. I want to say that I want to have Rider, which is at least 1.0, and we've got 3.0.14 installed. If I change that to 10, we can now see that that symbol has grayed out, and it's saying that this symbol isn't defined because we've got an unmet version constraint there. So it's a great way of telling you quite what's going on with your assembly definition files without, again, you having to swap to Unity. All right, so that's sort of working with your scripts. When you want to actually work with your code, you generally want to do some debugging as well. And so we've got all that information set up here. We've got automatically recognized that we've got a Unity project, and you can attach to Unity Editor or attach to Unity Editor and switch into play mode as well. Once we've selected one of those, we can just hit debug, and that will attach the editor, attach the debugger directly to the editor. And if I jump over here, and in fact, let's set a breakpoint first. Let's go to the main menu. And if we go to the title screen, no, it's not the title screen, is it? It's the level select menu there. We can set a breakpoint, or we've already got one set. And then if I start playing this, of course, Unity will just quickly compile again after I've made some more changes. And we've started the app running, there's the game running. And as soon as I hit the level select menu, we're in the debugger. and we get to see the expected features that we've got there. We've got a call stack here. There's external code filtered out. If I undo the filter there, we can see all of our Unity engine code there. And in fact, I can actually double click that and we'll decompile the code and allow you to debug even inside the Unity code. Let's go back to my code there. A couple of useful things that the debugger gives you is to give you some of the context that you need when you're working with a game. So we show you the active scene straight away there. And if we open that there, we've got the active scene. You can see the name of it, the path to the file, but also you can see these game objects. So the debugger adds the game objects to the active scene there. And we can step into that. If we have a look at the canvas there, we can see what components the canvas has got attached to it. And we can also see then the child game objects that you've got there. And you can kind of keep going here as well and look at all the different components and child game objects. So you've effectively got a debugger view of the same hierarchy that's being shown in the editor. Except, of course, you can't work with the Unity editor right now because you're stuck at a breakpoint. We also show you the current game object, and if you open that out, again, you get the components and the children objects there as well. But right, let's just carry on with that. If we select a level there and we start a wave playing, let's just clear the log file for a second. Now, as the agents start coming in, we can see now we've got various messages. Let's just uncollapse those coming through on the debug log. If you're in the editor, that information is also useful to you while you're editing. And so we've got a Unity tab window here, which if I open that, it shows you all of the different log messages that are going on there as well. So we've got the log messages that are coming through right now, and we've got our call stack there, and we can click anything there. So I could click change health, and that's going to open the change health method in the editor. Same with take damage or attack home base there. And in fact, I can click on the class names as well as the actual line numbers that are going on there. Excuse me. Now, let's just quickly show something else with the debugger. Let's hide that window back. If we come back here and restart, got a couple of really nice features with debugging. If I right click on the debugger there, I can set up a condition such as current index equals 3. That means the fourth item comes along, with the fourth sort of agent comes in to try and attack, then the breakpoint will be hit. So I don't want this breakpoint to hit every time one of my agents comes at me, but I want when the sort of the fourth one comes in. So if we just wait a second as these items come through, then there we are. The breakpoint has been hit. So these conditional breakpoints, by right-clicking and setting in a condition here, is a great way of letting your game run and then debugging at a certain point. But one of the problems now is that I can't do anything with the editor here. So if I wanted to inspect what's going on as a game, as this particular case, if I've got a bug with the fourth agent for some reason, I can't inspect it because the debugger is stopped at the breakpoint. And if I just continue that, then I'm no longer stopped and I've missed my chance. We've got a great way of working with that with Rider. If you right click on your breakpoint again, down here we've got what we call a Unity pause point. If I just click that, the icon has changed here. And if we just restart let me just restart. If I just restart the wave there, and if we see the items come through, we're going to wait for our fourth item. And when that one starts, then we see now that the game switches into pause mode. So the breakpoint with our condition has now not suspended the execution of the code. It has told the Unity editor to go into pause mode. And now I can work with my level as you'd expect. I can sort of navigate around, select items, and work with things. So let's say I select my enemy there and make it float. And if I come out of pause mode, then we should see it floating. But I think we might be at the wrong angle for that. But we can edit items and we can work with items. We can change things, inspect stuff that's going on there, and then just come out of pause mode. and carry on working. The final thing that I'd like to show then is unit testing as well. So unit testing games is a very interesting topic, and Rider supports this. It'll look for anything in your code, anything in your project which is using the NUnit test framework there. I've got some tests here. I think it's from the collections package, but Rider has picked those up. And if we go to the top of the file, there we can see the class. We can just click on this green button here to run all, or indeed I can just run one method here. And if I do run all there, then Rider will go and connect to the editor and run. Oh, wait a minute, I need to come out of play mode. That should be it. Let's put that back to what it is. Run all of those there. And now the interesting thing about testing with Unity is that you need to be running these tests inside the Unity process. What Rider does is it connects to the Unity process. Oh, with the debugger, let's just stop the debugger and go back to my tests. And so Rider will connect to the Unity editor. It'll run the tests and it will report all those things within within Rider. And when you can see, then we've got all green tests here. But if there are any test failures, we'll have a stack trace. I can click that. I can navigate around, and I can work with the results of my tests in the code base that I'm using, which is a great way of working. So I think that is a very quick overview of what Rider can offer. It's got a lot of great features and functionality for working with your scripts. We show you your Unity project as a Unity project. You get to see assets and packages and everything. We've got lots of Unity-specific inspections. We will try and show you best practices before you switch over to the editor. We'll try and save you time from switching to the editor, finding an error, coming back, changing it, switching to the editor. And we index all of your assets as well. We know where your code is being used inside the assets. And we can show you the serialized data right in the editor. We can do find usages. We can rename event handlers and have that updated in the scene. And we've got great support for debugging as well. We'll give you great context for working with your debugger items and allow you to navigate around and find lots of things to use there. So I hope this has shown you some very useful features of Rider. Again, the most important things that I would say are the two keyboard shortcuts, Shift to go off and search anything, and I can very quickly navigate around. And then AltEnter to try and make quick fixes and changes, and to use that as entry points to navigate, refactor, and generate code. Thank you all for watching, and please download Rider and try it out with your projects today.
Thank you, Matt. I think that was exciting, especially the debugger topic in the end. That was cool. I like it.
I'm a big fan of all the debugger features in there. There's a lot of really good stuff you can do in the debugger, and it's a great way of finding out exactly what's going on with your game. So it's nice.
Yeah, and I suggest maybe we can cover the questions regarding the debugger right now, because I think they were quite useful for many. So can you maybe comment about this stopping the debugger without detaching possibilities and how it works also for like run mode tests?
Yeah, sure thing. So this was a question which was asked in the chat, and it's whether we can whether you have to sort of detach the debugger all the time. And you can leave the debugger attached to the editor all the time. You can leave it running and it's absolutely fine. However, you can also, you can then sort of switch it from play mode and back into normal mode. And in fact, if I just switch to my screen now, I can show you sort of how this works. So let me just show you that. There we go. I've got my version of Rider up and running here, and I've got the same demo project here as well. And incidentally, this is the new UI, so this is rather nice as well. The latest version of Rider has got a beta version of a refresh of the user interface, which is nice and all looks very nice. I'm a big fan, to be perfectly honest. What we can do is we can use the drop down here to select attach to Unity Editor, hit the big debug button, and then we start debugging. And now we're sort of in debug mode, but there's no reason for us to actually be in run mode in the editor either. So we can carry on and keep on working with the editor as it is. However, if we go to the debug window here, there's a button at the end here called Mute Breakpoints. And if you click this on, that temporarily disables all of your breakpoints. So you're not going to hit a breakpoint right now. It's just going to stay attached to the debugger and allow you to carry on working, but it's not going to hit any breakpoints. The key thing about this is remembering to hit it again to turn your breakpoints back on again. But what you can do as well is use these play and pause buttons from the toolbar if you're connected to the Rider editor, sorry, the Unity editor. And you can use the play and pause buttons there to sort of switch you in and out of play mode very easily. So you can quickly click that button. That will start up play mode in the editor. There we are, we're in play mode. And while I can do it from the buttons here, I can also do the same from Rider here. If I just click the button again, it toggles it, and you can see now we're back at the in edit mode. So you can just leave the debugger attached, it's not a problem.
Yeah, thank you, Matt. And maybe you can also comment about the UI being completely different now at the screen compared to the previous talk. I'm not sure if people mentioned that. But the UI is kind of different. What has happened?
Yeah, so in this last release, we've been working on just refreshing the user interface of Rider. We've still got the old UI available. So if we go into settings, and if we go to the appearance, we've got a new UI item here. You can just click enable new UI, restart Rider, and you can try the new version of the user interface. There's still some things which we need to do to make it work nicely with Rider. It's still not, it's effectively a beta version, but it gives you a great example of the sort of the direction we're going in. It's just a bit cleaner, a bit fresher. We've got the same features that you know from the existing Rider. So if I just open up a file there so we can see what's going on. You've got your tool windows, and you can easily toggle those open. So with your commit window as well, you've got your tool windows down at the bottom. You can toggle those open as well. And it's just a bit more cleaned up. You know, the toolbar is fresher and cleaner. You can see your projects. You can see your version control windows there, and everything's just a little bit nicer, really. It's I'm a big fan, to be honest. Once you give it a go, you don't tend to go back.
Thank you. And like while we're on this topic, talking about the new things coming in 2023, maybe you can share with the audience like some things which are coming in terms of Unity support to Rider this year. So do you know any fancy stuff?
Yep, absolutely. So we're working on the next version right now, and we've got a few things which we've got lined up. One of them is to sort of improve how we deal with serialized references. So we can easily mark things right now as serialized fields, and we can show you where they're being used in assets and so on. But the Unity has changed the way it does some serialization. It's added extra features, so you can have use the serialized reference attribute to mark a field, which is, say, an interface, and then you can serialize all derived classes of that interface. And so it's then trying to find the fact that your derived classes have got serialized fields and show all the nice features that we do with serialized fields on these classes, which are defined somewhere away from your mono behavior. So we're doing some work with that. We want to add some support for dots. Now that the data-oriented tech stack is hitting 1.0, we're going to add some support in there for that. We'll talk more about that as the release goes on. We also want to finally address Android USB debugging as well. So we can, of course, debug all the different standalone players and the consoles and so on. In fact, I can just quickly show you that. I've still got my screen up. In this little Unity button at the top here, we've got this attached to Unity processes, and that pops up and gives you a nice little dialog which will list all of the players that are running around you on the network or on your local machine, also with the consoles and so on. And right now it supports iOS USB debugging, but we want to add Android USB debugging in there as well for the next version. A couple of other things as well for the next version, which is going to be F1 online documentation support for Unity packages. So if you are using Unity packages, you'll be able to get straight to the documentation of the APIs by hitting the F1 key. And yeah, and a few other things as well, hopefully. We'll see what we can fit in during development.
Thank you. And I guess no ChatGPT integration. It was asked in the chat if we plan any.
I'm going to get ChatGPT to do all of my demos. I think it might be easier.
Yeah, maybe. Okay, let's maybe back to some other questions in the chat. So there was a question about the filtering external code. So the question was, will filtering external code make it so you don't have to step through mono behavior when debugging and step in through code? So I guess it requires some more detailed explanation on how filter external code works, actually.
Yes, I'm not quite sure the context of that question, sorry.
I'm not quite sure either. Maybe we need some more details, but maybe you can explain once again, how filtering external code works, and that will help us.
Yeah, just reading through that comment there. Yeah, I'm not quite sure what that's going on. But right now, if you're debugging mono behavior, you can step into external code, and that external code could be Unity's own mono behavior classes or data from classes from a package, and you can step into that code, and Rider will sort of decompile it on the fly, or it'll use the source code from the packages that are available when you download the packages. And Karen, working with that, you can also sort of disable that already. You can disable the sort of decompiling on the fly, and so then you would only be able to step into sort of just your code, as it were. So that should be something which already works.
Okay, so hopefully that answers. So Rob is trying to elaborate in the chat, but I'm not sure if the answer is enough or requires more comment.
Yeah, I think that's actually the same sort of what I was trying to explain there. So yes, normally when you're debugging code, normally you only sort of debug your own code. But if you step into third-party code, such as some of the Unity methods and classes, Rider can decompile those and work with those. Allow the debugger to step through that. You can turn that off in the debug options right now. You can also step into packages, because packages are distributed as source and compiled by Unity and compiled in debug mode. So you can step into that with the source and work with those as well. And I think there are options there to sort of disable that for third-party code. And so you only debug just your code. So that should already be working under the debug options in the settings.
Yeah, okay, thank you. Also, there was a question in the chat. Well, you covered that in the video, but maybe we can repeat. So where to find the list of Unity inspections? I mean, the full list is meant, or some details on the inspections.
Yeah, sure. So again, if I just pop up my screen, I can show you what's going on there. There's a couple of things we can do. If I just go to one of my inspections classes here, if I look at null objects, this is a good one. Yeah, because we've got this this interesting thing about if you compare a mono behavior to null, that's doing more than just checking to see whether the C# object has been created or is null. It's checking to see whether the underlying Unity game object is still alive. And if you use something like the double question mark operator here, which is saying, use MB or use this, or if that's null, then use add component to create a mono behavior, that bypasses this extra check that the mono behavior does. And so we're kind of warning you here to say, are you sure this is doing what you think it's doing? That is a sort of complicated thing. And one of the things we've got here, this was mentioned in the video there, but one of the really useful things you can do is if you do Alt-Enter, go to the inspection menu here, and then down the bottom you've got this why is Rider suggesting this, and clicking on that will open off screen there it is, a web page which has got a full sort of detailed explanation of what's going on there. It tells you what the warning is all about, what the sort of inspection is doing, and also how you can hopefully sort of work around it, change your code, or make something a bit better. If you, from this page here, if you just go to the wiki, then that lists all of the code inspections that we've got there. So it gives you a list of everything. It explains everything that's going on, and it also sort of, again, tries to explain how you can work around it, why you're being told about it, and why you should change your code. So it's trying to give you the sort of the best practices and explain why they're best practices. It'll link off to the Unity documentation if possible, and also show you how to fix it as well. So we're not just spamming you with warnings here. There's a reason behind them, and you can find that out. This is all hosted on GitHub. We've got a ReSharper Unity project here, github.com, JetBrains ReSharper Unity. This the Unity support began life as a plugin to ReSharper, which is another product that JetBrains builds, and it's sort of shared between Rider and ReSharper here, so that everything is all available under there. It's in the wiki, and you can find it. Easiest way, though, is Alt-Enter, go to the inspection menu, and then why is Rider suggesting this?
Yeah, and I have to say, you can also get there through our web help. So if you go to the Unity pages in Rider web help, you can also go to this page on GitHub and find the same list. Actually, I quite like how Rider is trying to explain why on earth everything is happening in my code and trying to help me. So yeah,
we've got this available for. Sorry, we've got this available for a lot of inspections as well, not just the Unity specific ones, but a whole bunch of C# and various other inspections. They've got these here as well. So that's a great tip to look into this menu to find some help options.
Yeah, and a great way of learning, I guess.
Very much so, yeah.
C# in general. Yeah, right. Okay, so and talking about learning, so if the people would like to play with the project you were showing in the demo, so can they find it also on GitHub?
Yep, that's handy. I've got that link right there. It's yes, it is. So this is this project is it's a nice demo project. It's based on Unity's tower defense sample asset, which you can download from the asset store. So you can just create a project straight from there, and you've essentially got this project. But if you want, my version of the project has got this inspections folder here, which is great, with all of these little inspections files, which can give you inspections and ways of fixing them to show you what Rider can do, really. You know, for example, here, the mono behavior must be created using add component rather than not. So if you go to my GitHub page, it's github.com, citizen Matt, and then tower defense. And it's just there. There's no help page, unfortunately. It's just a simple project, and you can fire it up and have a go with it and see how you get on with using Rider. Find the inspections folder, and it should be there. In fact, I should be able to just type inspections, and there we go. We've got all the meta files, but the folder is going to be in there somewhere. Tower defense, and there we go. There's my inspections folder with some useful examples of some of the inspections that Rider can do for you.
Cool, thank you. So, and maybe the last question for today for you, Matt. So, does Rider support debugging standalone players and consoles?
Yep, definitely. We support all of the different players and everything. So we can connect. We've got sort of one-click attaching to the Unity editor, so we can attach to the Unity editor, and play. But we can also attach to standalone players. So if you just launch one of your standalone players, whether it's on the desktop, you can go down to this attach Unity process, and it will just be listed in here for you. So it'll find standalone players on the desktop, Windows or Mac players. It will also find mobile devices that are connected to the same network over Wi-Fi. And it'll also find consoles as well. So we work with all of the different consoles, and we connect to them. As long as you can talk to them via Wi-Fi, we'll be able to see those and connect to them and debug them as normal. All of the builds which are IL to CPP, such as the console builds, they all just debug normally as well. And you can just attach them, run it, attach them, and go for it. If you don't see your item listed in here, you can and you can know what the host and port is. You can attach it sort of manually. And down here, there's a little bit of blurb at the bottom, a little bit of text at the bottom of this dialog here, which kind of gives you a bit of information here. There's a link here to a troubleshooting guide, which again is on that wiki, which has got the inspections, and it tries to explain why you might not see things and how you can get it working. So, my device doesn't show up in the list. It's like, well, okay, how can we make sure it's working? And again, it's some useful information, such as it's got to be a development build, you've got to have script debugging enabled, but also you've got to make sure things like firewalls are correctly set up as well. Because everything's going over the Wi-Fi, over the network, sorry, then you need to make sure that we can actually see the device that's going to be debugged. But there's a lot of great help in there as well.
Yeah, indeed. Thank you. Thank you, Matt. So thank you. I think that's it in terms of the questions. And I just wanted to say that you can find more information about Rider on our website and in our blog, and you can follow us on Twitter, and you can watch more videos on our channel. There is a dedicated game dev playlist. You can find it, lots of videos about Rider and other tools. And you can get more Unity-related tutorials and tips in our web-based .NET guide by this link in the bottom. And so thank you for joining us today, and see you soon at our next game development webinar. Bye.
Bye-bye now.